Hello there, and welcome. I'm glad you found your way here. Maybe you had a long day, your mind still humming with the energy of it all? Or maybe you are the kind of person who finds a strange comfort in drifting off to deep, quiet thoughts rather than counting sheep. Whatever the reason, tonight's journey is for you. You have nothing to do now but rest. There is no list to complete, no problem to solve. Let your mind relax, your breathing slow, and your body grow heavy, as if gravity itself has softened its hold just for you, because tonight we will gently wander through our own cosmic backyard, the solar system. Not as a map to be memorized, but as a place of profound peace and patient beauty. A silent dance of worlds turning in the vast black velvet of space, each following its own slow and ancient rhythm. But beneath its familiar surface, this system holds deep secrets. We will listen to the silent magnetic song of the giant planets. We will drift through the scattered, icy garden of the asteroid belt. We will ponder the gentle, billion-year heartbeat of our sun. Some of what you hear may surprise you, or at least spark a quiet curiosity as you drift away. We will travel gently from the sun's warm hearth all the way out to the frozen, twilight realm where distant comets are born. And just before we begin, if these calm scientific explorations help you unwind and find rest, consider liking this video and subscribing to the channel. It is a very gentle way to help other weary wanderers find their way here too. One sleepy soul at a time. Now let us begin our drift. The sun's gentle hearth. The sun does not burn with fire, but with a slow, patient transformation. This is the process of nuclear fusion, where atoms of hydrogen gently press together and become helium, releasing light as a quiet byproduct. For over 4.5 billion years, this reaction has continued in the stellar core. It is a steady, cosmic heartbeat, converting mass into a soft, warming glow that travels outward to all the waiting worlds. Our star is a massive, slowly spinning sphere of incandescent plasma. It is not a solid body, but a flowing gaseous ocean with different layers turning at different rhythms. The equator completes its rotation once every 25 days, while the polar regions take nearly 35. This differential rotation twists the sun's magnetic fields over immense timescales, a lazy, cosmic dance that builds up energy with infinite patience. The light that gently warms your skin on a quiet afternoon began its journey long ago. A single photon created in the sun's dense core may take 100,000 years to slowly drift and bounce its way to the surface. Once free, it then races across the void, taking a mere 8 minutes to reach Earth. The sunlight you feel is both ancient and instantaneous, a messenger from a different age. Sunspots are the star's temporary, cooler freckles. These dark patches appear where powerful magnetic field lines like submerged ropes push up through the photosphere, inhibiting the flow of heat from below. They come and go in a cycle that averages 11 years, a slow pulse of magnetic activity. We do not fully know what drives the precise timing of this rhythm, but we observe its gentle, recurring pattern. The sun's outer atmosphere, the corona, is a beautiful, wispy halo of plasma that stretches millions of kilometers into space. Strangely, it is hundreds of times hotter than the visible surface below, a mystery that still puzzles solar physicists. This superheated crown is not a fierce fire, but an extremely tenuous and faint glow normally hidden by the sun's brilliance, only visible during a total eclipse as a delicate, pearlescent lace. A gentle wind constantly flows from the sun, a stream of charged particles spreading out in all directions. This solar wind is not a raging storm, but a steady, ethereal exhalation. It travels past the orbits of all the planets, pushing against the thin gas between the stars, creating a vast protective bubble around our solar system known as the heliosphere. We are all riding within the sun's soft, invisible breath. Sometimes the sun releases vast loops of plasma that follow the arc of its magnetic fields. These are prominences, and they can hang suspended in the corona for weeks or even months, glowing quietly. They are immense structures, often large enough to swallow our planet many times over. Yet they drift and coil with a slow, balletic grace, their motion almost imperceptible from one day to the next. The quiet fusion in the sun's core is a process of gradual consumption. Every second, the sun converts over 600 million tons of hydrogen into helium. This sounds like a furious rate, but for a body so colossal, it is a stately and sustainable pace. The sun has used only about half of the hydrogen in its core over its entire lifetime, leaving fuel for billions of years of future, gentle shining. We do not know exactly how the sun's magnetic dynamo will behave in the distant future. Its cycles of activity may grow stronger or weaker over immense stretches of time. For now, it remains a stable, nurturing anchor, its gravity the unseen hand that holds the planets in their orbits. Its constant pull is a quiet promise of order, a cosmic center around which our world patiently turns. In its final stages, billions of years from now, the sun will gently swell into a red giant. It will not be a violent explosion, but a slow, inevitable expansion, its outer layers cooling and drifting outward. For a time, it will fill the sky of what was once Earth, a vast crimson orb of quiet light. This is the distant, peaceful end of a long and steady life, a final, slow exhalation of a star that gave light for so long. The inner worlds. Rock and memory. Mercury is a world of quiet extremes, a planet of twilight and memory. Its surface is a mosaic of ancient craters, untouched by wind or water for billions of years, recording every impact from the solar system's violent youth. With almost no atmosphere to hold heat, the side facing the sun bakes, while the dark side faces the deep cold of space. It is a silent, scarred world, a museum of the early solar system, holding on to its stories in the sun's close embrace. Venus is wrapped in a thick, cloudy veil, a permanent and gentle shroud. Below those clouds, the surface tells a story of a different kind of planet, one with vast plains of volcanic rock and mountains shaped by immense, slow-moving forces. The pressure at the surface is crushing, and a gentle rain of sulfuric acid falls through the upper atmosphere. We do not know why Venus, so similar to Earth in size, evolved into such a different world. A perpetual, warm mystery. Earth, from a distance, is a delicate marble of blue and white, a world of quiet, persistent motion. Its tectonic plates drift at the pace of a growing fingernail, patiently reshaping continents over millions of years. The thin, life-giving atmosphere is a fragile blanket, a mere skin of gas that protects everything within it. This is the only world we know that breathes, a living planet adrift in a vast, quiet sea of space. The moon is Earth's constant, silent companion, a world of profound stillness. Its gravity gently tugs on our oceans, creating the slow, rhythmic pulse of the tides. The footprints left by Apollo astronauts remain perfectly preserved in the lunar dust, untouched by wind or water, a quiet testament to a fleeting visit. It is a world without sound, where shadows are sharp and black, and the only movement is the slow, patient journey around its parent planet. Mars is a world of gentle, rusty beauty, a desert planet holding the whispers of ancient water. Its canyons are vast and silent, and its mountains are the tallest in the solar system, built by slow volcanic forces over eons. The thin Martian air sometimes stirs, creating dust devils that dance silently across the plains. We do not know for certain where all its water went, but the dry riverbeds and lake beds remain, a quiet memory of a wetter, warmer past. The surface of Mars is painted in shades of ochre and rust, a color that comes from iron oxide, the same compound that gives earthly rust its hue. This dust is fine as talc, and over billions of years it has gently settled over the entire planet, blown by soft winds. There are polar ice caps that slowly grow and recede with the Martian seasons, made of water ice and frozen carbon dioxide. It is a world colored by slow oxidation, a quiet red jewel in the night sky. Earth's atmosphere is a protective membrane, a soft shield that most of us never consider. It gently burns up small meteors which we see as fleeting shooting stars. It scatters the sun's blue light, painting our daytime sky, and it holds in just enough heat to create the gentle conditions for life. This thin, invisible layer is all that stands between the biosphere and the void, a fragile bubble of air that we all share. The inner solar system is a realm of rock and sunlight, a neighborhood of worlds built from dust and metal. These terrestrial planets, Mercury, Venus, Earth, and Mars, are the dense, solid siblings that formed close to the sun's heat. They are the storytellers of the solar system, their surfaces bearing the quiet marks of impacts, volcanism, and, in one special case, the gentle persistence of water and life. They are the keepers of ancient memories written in stone. We do not know if life ever stirred on the other inner worlds. It may be that microbial life quietly emerged on a warmer, wetter Mars billions of years ago and then gently faded away. Perhaps in the thick, acidic clouds of Venus, some strange, floating chemistry persists. For now, these are open questions, mysteries, that add a layer of quiet wonder to our rocky neighbors, reminding us that our own world's story is just one of many possible tales. The asteroid belt between Mars and Jupiter is not a dense, chaotic field of crashing rocks as often imagined. Instead, it is a vast and mostly empty space where millions of small, rocky bodies slowly orbit the Sun. The largest series is now classified as a dwarf planet, a round world with a rocky core and a mantle of water ice. These asteroids are the leftover building materials of the solar system, the quiet remnants of a planet that never formed, forever drifting in the gentle sunlight. The asteroid belt, a scattered garden. The asteroid belt is not the cluttered junkyard of popular imagination, but a vast, scattered garden of ancient rock and metal. Millions of objects orbit the Sun in this broad region between Mars and Jupiter, each following its own lonely path. The average distance between any two asteroids is so immense that a spacecraft can drift through without a single close encounter. It is a place of profound quiet, where the dominant sound is the silent music of orbital mechanics playing over eons. These wandering bodies are the leftover building blocks of a planet that never was. In the early solar system, the gravitational influence of the giant Jupiter gently stirred this material, preventing it from ever coalescing into a larger world. They are the pristine remnants of that primordial era, frozen in time. We do not know exactly why Jupiter's influence was so disruptive, but the result is this beautiful, fragmented collection of solar system fossils. The largest resident of this scattered garden is Ceres, a round dwarf planet that holds a secret ocean. Deep beneath its rocky, cratered crust lies a vast reservoir of salty water, a world unto itself. This makes Ceres not just a rock, but a potential habitat, a place where the simple ingredients for life may have quietly mingled. It is a gentle reminder that water, the softness of life, can exist in the most unexpected of places. Most asteroids are not solid monoliths, but loose collections of rubble gently held together by their own meager gravity. These rubble piles are like cosmic sandcastles with vast empty spaces between the boulders and grains. When they slowly collide, they do not shatter but gently merge or drift apart, their structures absorbing the impact. They are fragile, temporary mountains wandering through the vacuum. The surfaces of many asteroids are covered in a fine, grey dust called regolith, a soft blanket created by billions of years of microscopic impacts. This dust settles gently over the irregular landscapes, smoothing out the contours of craters and ridges. There is no wind to blow it away, no rain to wash it clean. It simply accumulates, a silent record of the gentle, constant rain of space dust that falls throughout the solar system. Some asteroids are not content to stay in the belt and slowly drift inward on new journeys. Their orbits become gently stretched over time by the subtle, persistent tug of planetary gravity, particularly from Jupiter. These wanderers may eventually cross the path of Earth, becoming what we call near-Earth objects. They are pilgrims from the outer system, coming to visit the warmer inner worlds after ages in the cold. The composition of asteroids tells a quiet story of the solar system's birth. Some are dark and carbon-rich, pristine time capsules from the very beginning. Others are metallic, the exposed cores of what might have been tiny planets, their rocky outer layers stripped away by gentle collisions over time. By studying their spectra, we can read this story, a silent narrative written in reflected light. We do not know the exact number of these quiet wanderers. Our telescopes have catalogued over 1 million, but countless more, too small or too dark to see, are surely drifting in the darkness. They range in size from dwarf planets like Ceres down to mere pebbles. This vast population of unseen objects reminds us that what we can observe is only a fraction of the whole, a handful of stars visible from a vast, dark ocean. The Trojan asteroids are a special group that share an orbit with Jupiter, but never approach the giant planet. They cluster gently at 2 stable points in space, leading and trailing Jupiter in its path around the Sun. These are gravitational harbors, places of calm where objects can reside for billions of years, safely trapped in a cosmic dance. They are like quiet companions, a celestial entourage for a king. The beauty of the asteroid belt lies in its emptiness and its patience. It is a realm where time moves slowly and change is measured in millions of years. A collision is a rare slow-motion event. A shift in orbit is a gradual drift. There is no urgency here, only the steady, silent turning of countless small worlds, each a testament to the quiet, unfinished nature of our solar system's construction. Jupiter, the quiet king. Jupiter is a world of impossible scale, a gentle giant whose mass is greater than all other planets combined. It is not a solid body, but a vast, layered atmosphere that deepens into a sea of liquid metallic hydrogen. This colossal presence moves slowly, taking 12 of our years to complete a single, stately orbit around the Sun. It is the quiet king of our solar system, its reign defined not by force, but by a profound and patient gravitational influence. The most famous feature of Jupiter is its Great Red Spot, a vast swirling storm that has persisted for centuries. This immense anticyclone is a tempest of quiet fury, so large that Earth could be lost within its crimson clouds. Yet, from our distant vantage, it appears as a slow-moving, beautiful brushstroke on the planet's face. The storm is gradually shrinking, a gentle sigh in the planet's long atmospheric life, and we do not know when or if it will finally fade away. Jupiter's magnetic field is the largest structure in our solar system, a vast, invisible shield generated by the churning of its metallic hydrogen interior. This magnetosphere stretches so far that its tail brushes the orbit of Saturn. It is a silent, powerful force that traps and accelerates charged particles, creating intense radiation belts. This field is a gentle cosmic umbrella, helping to shape the space environment for all the planets that orbit within its vast domain. The bands of cream, orange and white, that stripe Jupiter are its zones and belts. Separate streams of atmosphere flowing in opposite directions at hundreds of miles per hour. These are the planet's jet streams, powerful winds contained within their lanes for thousands of miles. Despite their speed, the overall effect from a distance is one of serene, painted stillness, like a marble slowly turning in a silent room. The exact mechanism that creates this stable, banded structure remains a subject of quiet wonder. Jupiter's gravity acts as a gentle shepherd for the solar system. Its immense pull vacuums up many comets and asteroids that might otherwise travel inward, providing a protective buffer for the inner worlds. This role as a cosmic guardian is a passive one, a simple consequence of its mass. It does not actively defend, but its presence alone subtly cleanses the planetary neighborhood, a silent service performed over billions of years. We do not know if Jupiter possesses a solid core. Deep within the crushing pressures and searing temperatures, there may be a core of rock and ice, perhaps 10 to 20 times the mass of Earth, or the intense conditions may have dissolved this core long ago, leaving only a dense, diffuse concentration of heavy elements. The planet's deep interior remains one of the great humble mysteries, a secret hidden beneath thousands of miles of flowing hydrogen. Jupiter is a system unto itself, with a family of nearly 80 moons dancing in its gravitational sway. The four largest, Io, Europa, Ganymede, and Callisto, are worlds as complex as planets. From the volcanic fires of Io to the hidden ocean of Europa, each is a unique realm shaped by the gentle, persistent tug of their king. This miniature solar system around Jupiter mirrors our own, a quiet echo of orbital harmony on a smaller scale. The planet emits more heat than it receives from the Sun, glowing with a warm, internal energy left over from its violent formation. This primordial heat, slowly leaking out over billions of years, drives the complex weather patterns in its upper atmosphere. It is a world still cooling, still settling, its heart still warm from its birth. This gentle radiance is a faint whisper of the colossal events that once shaped our cosmic neighborhood. Jupiter's rings are a whisper-thin veil of dust, so faint they were undiscovered until spacecraft visited. Unlike Saturn's brilliant rings, these are created when micrometeorites gently strike the surfaces of Jupiter's small inner moons, kicking up dust that is then captured into orbit. They are not made of bright ice, but of dark, rocky particles, a subtle, ethereal halo that requires a careful gaze to perceive. To observe Jupiter is to witness a planet that is almost a star. It contains twice the mass of all other solar system matter outside the Sun, yet it fell just short of the nuclear fusion that would have ignited its own light. It exists in a state of quiet potential, a failed star that became a successful protector. Its great, striped presence is a reminder of the delicate balances in cosmic creation, a silent, gaseous sovereign in the dark. Saturn's ringed whisper. Saturn's rings are a breathtaking tapestry of ice and rock, a vast, flat disk that encircles the planet with silent elegance. They are not solid sheets, but countless individual particles, each following its own independent orbit around the giant world. From tiny, glittering ice crystals to boulders the size of houses, they drift in a harmonious, slow-motion ballet. Their collective reflection creates the illusion of a solid, luminous disk, a beautiful deception of scale and light. We do not know the precise origin of these magnificent rings. They may be the remnants of a small, icy moon that wandered too close to Saturn and was gently torn apart by tidal forces, or they could be the leftover building materials from the planet's own formation, dust and ice, that never coalesced into a larger body. Their relative youth suggests a dramatic birth, yet they now exist in a state of perfect, quiet equilibrium, a mystery wrapped in light. The rings are not a single structure, but a series of thousands of separate ringlets divided by subtle gaps. Some of these divisions are cleared by the gentle gravitational nudges of tiny, embedded moons. These shepherd moons orbit within or beside the rings, their small gravity sculpting the edges and creating waves and braids in the icy particles. It is a slow, continuous process of creation and maintenance, a silent collaboration between moon and ring. The primary component of the rings is water ice, incredibly pure and reflective, which acts like countless tiny mirrors for the distant sun's light. This is why the rings shine with such a brilliant, soft white glow. Over time, this ice is gently darkened by a fine dust of micrometeorites and rocky debris, a slow rain of soot that accumulates over millions of years. The rings are not a static monument, but a dynamic, evolving surface. Saturn's rings are whisper-thin, a breathtakingly delicate structure given their immense breadth. While they stretch over 280,000 kilometers from end to end, they are, in most places, less than 100 meters thick. If Saturn was scaled down to the size of a basketball, its rings would be thousands of times thinner than a single sheet of tissue paper. They are a cosmic illusion, a vast canvas painted on an impossibly slender surface. The particles within the rings are in a constant, gentle collision, bumping and nudging each other as they orbit. These impacts are not violent, but more like the soft tapping of billiard balls, helping to spread the particles out into their characteristic flat disk. This is a self-correcting system where energy is dissipated through these quiet interactions, maintaining the ring's exquisite flatness over astronomical timescales. The Cassini division is the largest and darkest gap in the main rings, a black band that seems to split the system in two. This emptiness is not random. It is orchestrated by the moon Mimas. With each orbit, Mimas gives the ring particles at that specific distance a consistent gravitational pull, like a steady rhythm on a swing. This resonance slowly clears the region, sweeping it clean over millennia. It is a perfect demonstration of gravity's patient, musical rhythm. Saturn itself is a world of profound calm, a gas giant even less dense than water. Its pale yellow hue comes from ammonia crystals suspended high in its atmosphere, which is dominated by gentle, banded flows. The planet's internal structure is a mystery, likely hosting a core of rock and ice, enveloped by a deep mantle of metallic hydrogen. Its slow 29-year orbit adds to its character as a patient, unhurried wanderer. The rings are a temporary, albeit long-lived, feature in our solar system. Scientists believe they may be only a few 100 million years old, and they may slowly dissipate over the next 100 million more. The particles are gradually spiraling inward, drawn by Saturn's gravity, and will eventually fall as a gentle, continuous rain of ice onto the planet's cloud tops. We are living in a privileged moment to witness their silent, shimmering glory. Beyond the main rings lie the faint, ethereal Phoebe ring, discovered only recently. This vast, tenuous disk is tilted against the others and is composed of dark, dusty particles that seem to originate from the distant, captured moon Phoebe. It is a ghostly counterpart to the brilliant inner rings, a reminder that Saturn's gravitational influence creates beauty not only in the brilliant and bold, but also in the faint and almost invisible. The outer sentinels, ice and myth. Uranus rolls through its orbit on its side, a quiet rebel in the planetary family. Its rotational axis is tilted almost perpendicular to its path around the Sun, giving it the appearance of a slowly rolling blue-green marble. This unique orientation suggests a colossal, gentle impact with an Earth-sized body in the distant past, a merging or a graze that forever changed its spin. For nearly a quarter of its 84-year orbit, one pole is bathed in continuous sunlight, while the other rests in a long, deep twilight. Neptune is a world of deep, impossible blue, a color born from the gentle absorption of red light by methane in its upper atmosphere. It is the windiest planet in our solar system, with gales that race through its frigid air at speeds surpassing 1,000 miles per hour. Yet from our distant vantage, these storms are silent, ethereal patterns on a serene azure sphere. This contrast between its violent weather and its tranquil appearance is one of its most enduring mysteries. The interiors of these distant worlds are not of gas, but of ice. Uranus and Neptune are classified as ice giants. Their mantles are vast, superheated and pressurized slush of water, ammonia, and methane ices. This ice is not frozen solid, but flows in a thick, dense, fluid layer above a likely rocky core. They are worlds built from the chilled building blocks of the outer solar system, holding deep within them the memory of its cold beginnings. Uranus possesses a subtle, understated ring system, a collection of dark, narrow bands of dust and rock. These rings are not bright with ice like Saturn's, but are instead composed of material as dark as charcoal. They were discovered only by chance when they gently passed in front of a distant star, causing its light to flicker and fade. These faint halos are like the whispers of the planet, requiring patience and a careful gaze to be perceived. Neptune's great dark spot was a vast, Earth-sized storm that churned in its southern hemisphere, a sibling to Jupiter's famous spot. When the Voyager spacecraft flew past, it captured this swirling maelstrom, but when the Hubble Space Telescope looked years later, it had vanished. Storms on Neptune are transient, forming and dissipating with the seasons. A reminder that even on this distant world, the atmosphere breathes and changes over time. The magnetic fields of the ice giants are strange and complex, tilted and offset from the planet's centers. Uranus's magnetic axis is skewed by almost 60 degrees from its rotational axis and does not emerge from the planet's core. This suggests that the magnetic field is generated not in a deep, metallic core, but closer to the surface, within the electrically conductive slush of the mantle. It is a gentle, lopsided force field, a quiet mystery wrapped within another. The moons of these sentinels are quiet, icy worlds with stories of their own. Uranus's Miranda is a fractured puzzle with cliff faces 20 times deeper than the Grand Canyon, as if it was shattered and carelessly reassembled. Neptune's Triton orbits in the opposite direction of its planet's spin, a captured wanderer from the Kuiper Belt. Its surface is a frozen nitrogen landscape, with geysers that erupt gently, sending dark dust plumes into its thin, cold sky. We do not know the precise chemical mixtures that give Uranus its paler, calmer aquamarine hue compared to Neptune's deeper, stormy blue. It may be that a slightly thicker, hazy layer of methane ice in Uranus's upper atmosphere filters the sunlight differently, or some other unknown compound may be quietly tinting the atmosphere of one of these distant worlds. The reason for their different shades of blue remains a gentle, open question. The orbits of these planets are a study in deep time and patient rhythm. Uranus takes 84 Earth years to complete a single, slow circuit around the Sun. Neptune's journey is even more stately, requiring 165 years. Since its discovery in 1846, Neptune has not yet completed a single orbit. It is a world whose annual cycle is longer than a human lifetime, a slow, silent sentinel on the frontier of our solar system. These ice giants are the outermost planetary guardians, the last outposts before the solar system gives way to the vast, dark realm of the Kuiper Belt. They are colder and quieter than their gaseous siblings, holding more of the original, icy material from which the solar system formed. In their deep freeze and their slow, patient orbits, they are the gentle keepers of the solar system's distant, cold memory, whispering secrets on a timescale we can barely comprehend. The Kuiper Belt, ancient wanderers. Beyond the orbit of Neptune lies a vast, dark frontier, a realm of ice and mystery known as the Kuiper Belt. This is not a belt in the dense, clustered sense, but a colossal donut-shaped region of space, populated by countless frozen worlds. These are the remnants of the solar system's earliest building blocks preserved in a deep freeze for billions of years. It is a place of profound stillness, where the sun is merely a very bright star in a perpetual twilight sky. The most famous resident of this realm is Pluto, now understood not as a cast-out planet, but as a king of this frozen domain. Its surface is a complex tapestry of nitrogen glaciers, water ice mountains, and a vast, heart-shaped plain of frozen gases. Pluto has a thin, hazy atmosphere that freezes and falls to the ground as snow when it moves further from the sun on its long, elliptical orbit. It is a dynamic, active world, quietly challenging our ideas of what a small, cold body can be. Pluto is not alone in its dance. It is accompanied by its large moon, Charon, a world so sizable in comparison that they orbit a mutual point in space, forever locked in a gravitational embrace. This makes them a binary system, two partners slowly turning in the void. Their four smaller moons, Styx, Nix, Kerberos, and Hydra, trace complex paths around this central pair, a delicate, miniature clockwork of gravity and motion in the outer dark. The Kuiper Belt is the source of most short-period comets, those that return to the inner solar system on timescales of less than 200 years. Occasionally, the gentle gravitational nudge of a distant passing star or the slow orbital rhythms of the giant planets will dislodge one of these icy bodies. It then begins a long, slow fall sunward, a journey that may take thousands of years before it graces our skies with its glowing tail. We do not know the full population of this distant region, for its members are small, dark, and incredibly far away. Our telescopes have catalogued only a fraction of the larger objects, each new discovery a faint pinprick of light patiently tracked across the starfield. It is estimated that hundreds of thousands of these ancient wanderers may exist, a vast, unseen archipelago on the edge of our solar neighborhood. Some Kuiper Belt objects travel in profound resonance with Neptune, their orbits locked in a gentle gravitational dance. For every 2 orbits Neptune completes, Pluto makes 3. This stable rhythm ensures that Pluto and Neptune never closely meet, despite their paths crossing. This orbital harmony is a common feature in the Kuiper Belt, a quiet, mathematical music that prevents these distant worlds from being scattered into the darkness or pulled into the inner solar system. The objects here are not simply balls of ice. They are time capsules. Their surfaces are darkened by a layer of tholins, complex organic molecules created when simple ices like methane are bombarded by cosmic radiation over billions of years. This process gives them a reddish-brown hue, a patina of extreme age. These tholins are the precursors to the building blocks of life, suggesting that the raw ingredients for biology are quietly being assembled in the cold, outer reaches of our own solar system. There are wanderers in this belt that defy easy categorization, like Haumea, a world shaped not like a sphere, but like a flattened spinning football. Its rapid rotation, a day lasting less than 4 hours, has stretched it into this unique form. Haumea also possesses a faint ring system and 2 small moons, a testament to the surprising complexity that can emerge from the gentle collisions and mergers that occur in this distant, icy disk. Far beyond the classical Kuiper Belt, astronomers suspect the existence of an even more distant and mysterious region, the scattered disk. Here, objects follow wildly elongated and tilted orbits, suggesting they were gravitationally scattered by the giant planets in the solar system's youth. These are the true solitary wanderers, spending most of their time in the deep freeze of interstellar space, only occasionally visiting the planetary regions we call home. The Kuiper Belt represents the final frontier of our planetary system, a gentle transition zone between the Sun's realm and the vastness of interstellar space. Its inhabitants are the pristine, untouched remnants of our solar system's formation, the quiet, frozen notes of a symphony that began over 4 billion years ago. To contemplate the Kuiper Belt is to look into the deep, cold past, a place where time moves slowly, and ancient memories are held in ice. Comets, celestial travelers. A comet begins its life as a quiet, frozen stone in the distant darkness, a primordial mixture of ice, rock, and dust. For billions of years, it rests in the deep freeze of the Oort cloud or the Kuiper Belt, a preserved relic of the solar system's birth. Its journey inward is a slow, patient fall, initiated by a gentle gravitational nudge from a passing star or the subtle pull of the giant planets. It is a sleeper, awakened to begin a long pilgrimage toward the light. As a comet drifts closer to the sun, its frozen heart slowly begins to warm. The ices within it, water, carbon dioxide, methane, do not melt, but instead transform directly into gas in a process known as sublimation. This gentle outgassing releases dust that was trapped within the ice for eons. The comet begins to breathe, exhaling a vast, tenuous cloud of gas and dust around its nucleus, forming a glowing halo called the coma. The most iconic feature of a comet is its tail, a soft, ethereal banner that can stretch for millions of kilometers across the solar system. A comet actually grows two distinct tails. The dust tail, glowing with reflected sunlight, curves gently behind the comet's path like a slow-moving smoke trail. The ion tail, made of electrically charged gas, is pushed directly away from the sun by the solar wind, pointing like a cosmic weather vane in the steady breath of our star. The solid core of a comet. Its nucleus is often surprisingly small, typically just a few kilometers across. We sometimes imagine it as a dirty snowball, but it is more accurately a snowy dirt ball, a fragile, porous aggregate of rock and ice. Its structure is weak, more like a pile of gravel than a solid mountain. This fragility means comets can slowly break apart or even split in two from the gentle stresses of their own rotation and warming. Each pass by the sun is a gentle act of erosion for a comet. A short-period comet, like Halley's, loses a thin layer of its material with every orbit, leaving a trail of dust along its path. When Earth passes through this ancient debris, we witness a meteor shower as these tiny particles silently vaporize in our upper atmosphere. The shooting stars we wish upon are the gentle, final size of a distant, traveling comet. We do not know the exact number of these icy travelers residing in the distant Oort cloud. Estimates suggest it could be 1 trillion or more, a vast, silent reservoir of cometary nuclei surrounding our solar system. They are so distant and dark that we cannot see them directly. We only infer their presence from the few that are slowly dislodged and begin their long inward journey, becoming temporary visitors in our skies. The composition of a comet is a personal connection to our own origins. The ices and complex organic molecules found within them are the same raw materials from which the planets were formed. The water in a comet's ice has a chemical fingerprint, and studies suggest that a significant amount of Earth's water may have been delivered by cometary impacts in the planet's youth. The very water we drink may have once been carried on the long, cold journey of a celestial traveler. Some comets are one-time visitors, on orbits so long and elliptical that they will never return. They fall from the darkness, swing around the sun, and are flung back out into the deep, never to be seen again. Their appearance is a unique, fleeting gift. They remind us that the solar system is not a closed room, but a dynamic place with constant, gentle exchanges with the galactic environment beyond. The appearance of a bright comet has always been a deeply personal human experience, a silent messenger in the night sky that seems to speak directly to the observer. Unlike the fixed stars and wandering planets, a comet arrives unannounced, changes form, and slowly fades. It is a transient wonder that connects our brief, modern moment to the awe of all the generations who have looked up and seen the same celestial traveler. A shared moment of quiet mystery across time. A comet's journey is a cycle of sleep and awakening. After its close approach to the sun, it begins the long, slow return to the outer darkness. Its tail fades, its coma dissipates, and it returns to its dormant, frozen state. It will sleep again until its orbit brings it back toward the warmth, or until it is gently nudged onto a new path entirely. It is a perpetual wanderer, a quiet clock marking time on a scale that dwarfs human history, a gentle reminder of the slow, rhythmic pulses of the cosmos. Moons, a chorus of companions. Our solar system is not merely a collection of planets orbiting a star, but a nested system of worlds within worlds. Most planets are accompanied by moons, a diverse chorus of companions that range from tiny, captured asteroids to complex spheres larger than the planet Mercury. These are not mere specks of light, but unique landscapes, each with its own quiet story of formation and evolution, a testament to the miniature diversity found within a single stellar system. Jupiter's moon, Io, is a world of gentle, constant renewal, its surface painted in hues of yellow and orange by crystallized sulfur. It is the most volcanically active body in the solar system, its interior heated and kneaded by the relentless gravitational pull of Jupiter and its sister moon. Dozens of volcanoes continuously erupt, spewing plumes of material hundreds of kilometers into its thin sky, slowly resurfacing the moon in a quiet, persistent geological sigh. In stark contrast, another of Jupiter's moons, Europa, presents a world of serene, frozen beauty. Its surface is a cracked and fractured shell of water ice, resembling a cracked eggshell floating in space. Beneath this icy crust, however, lies a global salty ocean, containing more than twice the water found on Earth. This hidden sea, warmed by the same tidal forces that heat Io, is one of the most promising places in our solar system to look for the gentle whispers of life. The scale of moons varies dramatically, from the planet-sized to the minuscule. Ganymede, also orbiting Jupiter, is the largest moon in the solar system, even bigger than the planet Mercury. It possesses its own intrinsic magnetic field, a rare and quiet wonder. At the other extreme, Mars's moons, Phobos and Deimos, are small, irregular chunks of rock, likely captured asteroids that now trace quiet, swift paths across the Martian sky, no larger than a city. Saturn's moon, Titan, is a world wrapped in a thick, orange haze, a dense atmosphere of nitrogen and methane that hides its surface from plain sight. It is the only moon known to have stable liquids on its surface, though they are not water, but rivers and lakes of ethane and methane. Here, a gentle rain of organic compounds falls through the cold air, carving channels and pooling into vast seas in a slow, cold mirror of Earth's own water cycle. Some moons hold secrets that defy simple categorization. Enceladus, a small, bright moon of Saturn, spews giant plumes of water vapor and ice crystals from a subsurface ocean out into space. These geysers erupt from fractures in its south pole, creating a faint, ethereal ring of ice particles that feeds one of Saturn's broader rings. It is a world that gently announces its hidden ocean to the cosmos, a silent testament to the dynamic forces at play on the smallest of scales. The tiny moon Miranda, orbiting Uranus, is a world of quiet chaos, a fractured landscape of enormous canyons and jumbled terrains. It appears as if it was shattered by a colossal impact, and carelessly reassembled, its pieces frozen in a chaotic mosaic. We do not know the precise cataclysm that shaped it, but its scarred surface speaks to a violent past that has since settled into a profound and icy silence. Earth's moon is our constant, familiar companion, a world of profound stillness and stark beauty. Its gravity gently tugs on our oceans, creating the slow, rhythmic pulse of the tides that wash our coastlines. Its surface, marked by dark plains of ancient lava and bright, cratered highlands, has remained largely unchanged for billions of years, a silent record of the solar system's violent youth. Patiently orbiting just beyond our reach, we do not know how many more of these quiet companions await discovery. New tiny moons are still being found around the giant planets, and the distant Kuiper Belt objects are often accompanied by their own small moons. Each new discovery adds another voice to the chorus, reminding us that the solar system is filled with countless small worlds, each a unique expression of geology and gravity, from the colossal to the barely there. This chorus of moons illustrates a profound cosmic truth that even on the smallest scales, complexity and wonder can emerge. A moon can have its own underground ocean, its own atmosphere, its own active geology. They are not merely accessories to their planets, but worlds in their own right, a diverse family of quiet companions sharing the vast darkness, each a miniature world with a story told in ice and rock. The solar wind's unseen breath. The sun breathes a gentle, continuous wind into the solar system. This is not a wind of air, but a stream of charged particles, protons and electrons that flow outward in all directions. It begins in the sun's superheated corona, where the intense thermal energy allows particles to escape the star's gravitational pull. This solar wind is a soft, persistent exhalation, carrying the sun's magnetic field with it like an invisible, expanding bubble. This unseen breath travels at different speeds, a quiet rhythm of fast and slow streams. The fast solar wind, moving at over 800 kilometers per second, flows from coronal holes, which are cooler, less dense regions in the sun's atmosphere. The slow solar wind, half that speed, emanates from elsewhere. These two streams interact as they expand, creating vast, rotating patterns that sweep past the planets like the gentle arms of a cosmic weather system. The solar wind is incredibly tenuous, a near-perfect vacuum by earthly standards. At Earth's orbit, there are only a few particles per cubic centimeter, a whisper of matter drifting through the void. Despite this thinness, its effects are profound and widespread. It is a constant, gentle pressure, an invisible force that has shaped the atmospheres and magnetospheres of worlds for billions of years. A sculptor whose tools are particles and magnetic fields. Where this flowing wind encounters a planet with a magnetic field, like Earth, it creates a protected harbor. The planet's magnetosphere acts like a stone in a stream, diverting the solar wind around it. The two magnetic fields press against each other, forming a standing bow shock upstream and a long, trailing magnetotail behind. This interaction is a silent, dynamic dance, a pressure balance maintained in the quiet of space. At the poles, where Earth's magnetic field lines funnel down into the atmosphere, the solar wind paints the sky with light. Charged particles spiral along these lines and collide with air molecules, causing them to glow in shimmering curtains of green and red. These are the auroras, the visible signature of the solar wind's gentle interaction with our world. They are a silent, dancing proof of an energy transfer happening far overhead. The solar wind creates a vast protective bubble around our entire solar system called the heliosphere. This is the region of space dominated by the sun's influence, where the solar wind pushes against the thin, ionized gas that exists between the stars, the interstellar medium. The boundary of this bubble, the heliopause, is where the sun's breath finally stalls and merges with the galactic environment. We are all living inside this colossal, invisible structure. The pressure of the solar wind is gentle but persistent, and it can slowly strip away the atmosphere of a world that lacks a protective magnetic field. Mars, with its weak magnetic shield, has had its atmosphere eroded over billions of years by this process. The solar wind continues to slowly blow the thin Martian air into space, a quiet, ongoing loss that demonstrates the long-term, patient power of this unseen force. The sun's breath is not perfectly steady. It has its own quiet weather. Coronal mass ejections are billion-ton clouds of solar plasma that are occasionally released into the wind, creating a stronger gust. Solar flares can add bursts of energetic particles. Yet even these events, which seem dramatic to us, are but gentle sighs in the life of a star, temporary ripples in the constant, rhythmic flow of its outward wind. We do not know all the subtle ways the solar wind's composition changes over the sun's multi-billion-year life. Its flow and strength vary with the 11-year solar cycle, growing stronger and more turbulent at solar maximum. It carries with it the fingerprints of the solar corona, a region whose heating mechanism remains one of astronomy's great, gentle mysteries. The wind is a messenger telling us about the conditions in the sun's outer atmosphere. The influence of the solar wind extends to the most distant reaches, shaping the orbits of comets. As a comet approaches the sun and develops its ion tail, the solar wind pushes that tail, made of charged particles, directly away from the sun. This creates the comet's characteristic second tail, a straight bluish streamer that always points away from the solar breeze, a cosmic windsock in the steady flow of the sun's eternal breath. Orbits, the grand, silent dance. Every object in the solar system is engaged in a slow, silent dance held by the gentle, unseen hand of gravity. This force does not pull with a jerk or a tug, but with a constant, patient embrace that curves a straight path into an eternal ellipse. A planet's orbit is not a circle but a gentle oval with the sun resting at one focus, a quiet anchor for a billion-year waltz. This motion requires no fuel, only the initial momentum from the system's birth, a spin that has been gradually slowing over eons. The mathematics of this dance is a thing of quiet beauty, described by Kepler's laws of planetary motion. A planet moves faster when it is close to the sun and slower when it is far away, sweeping out equal areas in equal times. It is a cosmic rhythm, a slow inhalation and exhalation of speed that repeats with each orbit. The square of a planet's orbital period is proportional to the cube of its average distance from the sun, a harmonious relationship that holds true from Mercury to the farthest comet. We do not feel the Earth's incredible orbital speed of 67,000 miles per hour because it is so constant and smooth. There is no vibration, no roar of wind, only the silent, steady fall around the sun. Our planet is perpetually falling towards the star, but its forward velocity always carries it just beyond, creating a curve that never ends. This is the essence of an orbit, a perpetual state of falling and missing, a graceful, ethereal balance between motion and gravity. The planets do not orbit in a flat, two-dimensional plane as often depicted. Their paths are slightly inclined relative to one another, like records on a spindle, each spinning at a different, gentle tilt. Furthermore, their orbits themselves slowly rotate, a phenomenon called apsidal precession, where the long axis of the ellipse turns like the hand of a very slow clock, completing a cycle over hundreds of thousands of years. The stability of these orbits over billions of years is a quiet marvel. Small gravitational nudges from other planets constantly perturb each path, creating long-term cycles of change. Earth's own orbital eccentricity, the shape of its oval, slowly oscillates over a 100,000-year period. This gentle rocking, this rhythmic breathing of our path, is one of the subtle pacemakers of our planet's ice ages, a slow celestial rhythm imprinted on the global climate. Smaller bodies often dance in resonance with the giant planets, their orbits locked in a gravitational harmony. For every 3 orbits Neptune makes, Pluto makes 2. For every 2 orbits of Jupiter, an asteroid in the Hecuba gap makes 3. These resonances create empty bands in the asteroid belt, regions swept clean by the repetitive, gentle tug of a giant world. It is a silent, mathematical music that structures the solar system, preventing collisions and scattering. The Oort cloud, that distant shell of cometary nuclei, is so far away that its objects are barely bound by the Sun's gravity. Their orbits can be easily swayed by the gentle gravitational pull of passing stars or the tidal force of the Milky Way galaxy itself. These are the most delicate of dances, easily disrupted, sending a sleeper on a long journey inward. Their paths are not fixed but fluid, slowly changing over millions of years. An orbit is a path through curved space-time, a concept from Einstein's theory of general relativity. The Sun's mass creates a depression in the fabric of the universe, and the planets simply follow the contours of this gentle slope, like marbles rolling around a wide, shallow bowl. This curvature explains subtle orbital quirks, like the precession of Mercury's orbit, a tiny, slow wobble that Newton's gravity could not fully explain, but that Einstein's theory gently revealed. We do not know the ultimate fate of every orbit. Over trillions of years, the gradual loss of the Sun's mass and the gentle drag of the solar wind may cause the planets to slowly spiral outward. Tidal interactions may continue to subtly alter the paths of moons. The dance is not perfectly eternal. It is a system evolving with infinite patience, its rhythms changing on timescales that dwarf human history. A slow, grand unwinding. To contemplate an orbit is to witness a form of perpetual motion, a ballet set to a timescale we cannot perceive. From the swift 88-day year of Mercury to the 4,000-year journey of far, far out in the distant Kuiper belt, each path is a unique expression of the same physical law. They are the silent, elegant solutions to the equation of gravity, a grand, choreographed performance happening in the quiet theater of space. The solar system's dawn, our solar system began not with a bang, but with a gentle gravitational sigh. It formed from a vast, cold cloud of interstellar gas and dust, a nebula drifting quietly through one of the Milky Way's spiral arms. Then, a nearby event, perhaps the shock wave from a dying star, gently compressed the cloud, causing it to begin collapsing under its own weight. In the center, a dense, warm clump started to grow, the seed of our future sun. As this primordial cloud collapsed, it began to spin, slowly at first, then faster, like a figure skater pulling in her arms. This rotation caused the cloud to flatten into a giant spinning disk, a protoplanetary disk of gas and dust swirling around the newborn protostar. This disk was the nursery for all the planets, a warm, thin pancake of material where the building blocks of worlds would slowly, patiently begin to assemble. Within this dusty disk, the first particles began to gently stick together. Electrostatic forces, the same that make dust cling to a screen, caused microscopic grains to collide and adhere, forming pebbles. These pebbles, drifting in the nebular gas, continued to collide, growing into larger and larger chunks of rock and ice over thousands of years. This process, known as accretion, was the quiet, gradual beginning of planet formation. The inner region of the disk, close to the hot, young sun, was too warm for volatile ices to remain solid. Here, only metals and rocky silicates could condense and accrete. This led to the formation of the small, dense terrestrial planets, Mercury, Venus, Earth, and Mars. They are the hardened, refractory cores of the inner system, worlds built from the dust that could withstand the heat of the stellar hearth. Farther out, beyond the frost line, water and other ices could survive as solid particles. Here, planetary cores could grow much larger as rock and ice combined. Once these cores reached a critical mass, about 10 times that of Earth, they began to rapidly accrete the vast amounts of hydrogen and helium gas that filled the disk. This was the gentle birth of the gas giants Jupiter and Saturn, which swiftly grew to become the solar system's giants. The asteroid belt between Mars and Jupiter is a fossilized record of this early era. It is a region where the formation of a full-sized planet was gently prevented. The immense gravity of the growing Jupiter stirred up the material there, giving planetesimals too much energy to coalesce. Instead, they continued to orbit as a scattered population, a quiet remnant of the building process that was never completed. A period known as the Late Heavy Bombardment likely occurred several 100 million years after the planets formed. It was a time when the outer solar system appears to have been dynamically shaken, perhaps by the migration of the giant planets. This sent a rain of asteroids and comets hurtling into the inner solar system, gently pummeling the young terrestrial worlds. The craters on the Moon are the quiet, enduring scars from this ancient, formative time. We do not know the precise sequence of events that led to the Moon's formation. The prevailing theory suggests a Mars-sized body, often called Theia, gently collided with the early Earth. The impact vaporized part of both worlds, and from the debris ejected into orbit, the Moon slowly coalesced. This gentle, giant impact explains the Moon's composition so similar to Earth's mantle and its lack of a dense iron core. The solar system's architecture was not fixed at its birth. Models suggest that giant planets may have migrated from their original orbits. Jupiter may have drifted inward before being gently pulled back by Saturn's gravity. This grand tack, as it is called, would have sculpted the asteroid belt and influenced the small size of Mars. The solar system we see today is the settled result of these slow, early gravitational rearrangements. The final act of planet formation was a gentle clearing of the remaining debris. The young, radiant sun developed a strong solar wind that began to blow away the leftover gas from the protoplanetary disk. The gravitational influence of the newly formed planets either ejected remaining planetesimals to the distant Oort cloud or swept them up in collisions. Over a few 100 million years, the chaotic disk became the relatively clean, quiet, and stable system we know today. Distant lights and future sunsets. The future of our solar system is written in the slow, steady evolution of the sun. For billions of years, it has burned hydrogen in its core with a stable, gentle light. But this cannot continue forever. In about 5 billion years, the sun will begin to exhaust the hydrogen fuel in its core, marking the end of its long, quiet main sequence life. This is not an end, but a transition into a new, more expansive phase of its existence. As the core runs low on hydrogen, the sun will respond by slowly expanding. It will not be a violent explosion, but a gradual, inevitable swelling. The outer layers will push outward, and the sun will evolve into a subgiant, then a red giant. Its radiance will increase, bathing the inner planets in a warmth that slowly grows more intense. This process will unfold over hundreds of millions of years, a stately and patient transformation. Mercury will be the first world to be gently reclaimed by its parent star. As the sun's outer atmosphere grows, it will slowly engulf the small, rocky planet. There will be no violent collision, but a gradual spiraling inward as Mercury's orbit decays through friction with the tenuous solar material. It will finally be vaporized, its substance quietly returned to the star from which it originally came. Venus and Earth will face a similar, though delayed, fate. The sun's expanding outer layers will reach the orbit of Venus, and the planet's thick atmosphere will be stripped away by the increased solar wind. The surface will be scorched, and the world will be transformed into a molten sphere. Earth's orbit will also lie within the sun's outer envelope. The oceans will boil away, the atmosphere will be lost to space, and the rocky crust may itself melt, becoming part of the star's extended atmosphere. During its red giant phase, the sun will not be a tight yellow sphere, but a vast, bloated orb of crimson light. It will be thousands of times more luminous than it is today, though its surface will be cooler, giving it its red hue. From the perspective of the outer planets, the sun will appear as an enormous, dim red disk filling a large portion of the sky, a quiet, majestic, and slowly changing celestial presence. The increased energy from the giant sun will gently thaw the frozen moons of the outer planets. Europa's icy shell will melt, turning its subsurface ocean into a warm, global sea exposed to space for a temporary era. The methane ices on Titan will vaporize, creating a thick, complex atmosphere that may, for a brief period, resemble the early Earth's, before it too is stripped away by the solar wind. Eventually, the sun will become unstable, unable to support its own immense, diffuse outer layers. It will gently pulse, ejecting its outer atmosphere into space in a series of quiet, luminous bursts. This ejected material will form a beautiful, glowing shell of gas around the dying star, a planetary nebula. This nebula will expand slowly into space, its intricate shapes and colors a final, gentle monument to the star's long life. What remains after this gentle expulsion is the sun's core, a white dwarf. This Earth-sized remnant will be incredibly dense, a hot ball of carbon and oxygen that will no longer undergo fusion. It will simply glow with residual heat, a fading ember in the darkness. It will take trillions of years for this white dwarf to cool completely, becoming a cold, black dwarf, a dark and silent stone in the void. The orbits of the surviving planets will be profoundly altered. With the sun having lost nearly half of its mass, its gravitational grip will weaken significantly. The remaining planets, Mars, the gas giants, and the ice giants, will slowly migrate outward, their orbits expanding in a grand, slow-motion relaxation. They will continue to circle the dark, cooling white dwarf, their surfaces lit only by the faint, dimming glow of the stellar remnant and the distant, steady light of the galaxy. We do not know if any of the surviving worlds will retain their moons, or if their own internal dynamics will be affected. The gentle, rhythmic systems of tides and orbital resonances will be reset. The future solar system will be a much darker, colder, and quieter place, a ghost of its former self, where the long, patient process of cosmic decay and cooling will continue on timescales that stretch far beyond our imagination. Our place in the spiral, our solar system is not an isolated island, but a tiny, integral part of a much larger structure, the Milky Way galaxy. We reside within one of its spiral arms, known as the Orion Cygnus arm, about halfway between the glowing center and the dark, quiet edge. From our position, the galaxy appears as a faint, milky band arching across the night sky, a cross-section of the vast, spinning disk in which we are embedded. We are citizens of this grand, starry city. The Milky Way is a gentle, spinning carousel of stars, gas, and dust, and our solar system moves with its flow. We orbit the galactic center at a serene pace of about 230 kilometers per second, yet it still takes us approximately 230 million years to complete a single, grand orbit, a span of time known as a cosmic year. The last time we were in this position, the dinosaurs were just beginning their long reign on Earth. As we journey around the galaxy, our entire solar system bobs gently up and down through the galactic plane. Much like a floating cork on a calm ocean, we oscillate with a rhythm that takes us above and below the central disk every 30 to 40 million years. This slow, vertical dance may subtly influence the influx of comets from the Oort cloud, a gentle cosmic rhythm that could have played a background role in the long-term story of life on Earth. The galaxy is not a random scattering of stars, but a structured system with its own quiet weather. Our solar system moves through the local interstellar cloud, a region of slightly denser gas and dust that we have been drifting within for tens of thousands of years. This cloud is itself nestled inside a vast, empty bubble in the galaxy called the local bubble, carved out by ancient supernovae that gently pushed the interstellar material away. The galactic environment provides a constant, gentle rain of material onto our solar system. Every day, tons of interstellar dust and gas, the raw ingredients of new stars and planets, drift into the heliosphere. Most of it is deflected by the solar wind or the sun's gravity, but a small amount is captured, adding its ancient, foreign atoms to the reservoir of our system. We are constantly, quietly exchanging material with the wider galaxy. Our location in the galaxy is a fortunate one, a place of gentle balance. Too close to the crowded center, and the intense radiation and gravitational tides would likely have disrupted the stable planetary orbits needed for life. Too far out in the sparse, dark halo, and there would have been too few heavy elements to form the rocky planets that serve as our home. We exist in a quiet, habitable zone on a galactic scale. The Milky Way is itself on a long-term journey, slowly moving through the local universe. It is gravitationally drawn toward its massive neighbor, the Andromeda Galaxy. Billions of years from now, the two galaxies will begin a slow, graceful dance, eventually merging to form a new, larger galaxy. This galactic collision will likely happen with so much space between stars that our solar system will pass through unscathed, witnessing a brilliant rearrangement of the night sky. The light from distant stars that we see tonight is a message from the deep past. The photons that enter our eyes have traveled for years, decades, or millennia across the galactic expanse. When we look at the band of the Milky Way, we are not seeing a static picture, but a composite of light from different eras. A tapestry woven from the past glows of countless suns, all reaching us now in a silent, beautiful chorus. We do not know if our solar system is unique in its composition and arrangement within the galaxy. With hundreds of billions of other star systems, it is statistically likely that there are others with rocky planets in temperate orbits. Yet, the specific combination of events that led to our system, the particular mix of elements, the timing of planetary migrations, the existence of our large moon, may be a quiet, singular story in the vast galactic library. To understand our solar system is to see it as a single thread in the galaxy's grand tapestry. The iron in our blood, the silicon in our rocks, and the oxygen we breathe were all forged in the hearts of long-dead stars that lived and died before our sun was born. Their explosive deaths seeded the galactic cloud that gave us form. We are not just in the galaxy. The galaxy is within us, a permanent quiet connection between the cosmic and the personal. And now, the planets begin to dim behind your thoughts. The silent dance of orbits slows to a gentle halt in the quiet theater of your mind. We have drifted together through more than 100 quiet truths, from the sun's warm, gentle hearth, out past the ringed whisper of Saturn, through the scattered garden of asteroids, and all the way to the icy, ancient wanderers in the distant dark. You have wandered across the rust-colored plains of Mars, gazed into the stormy blue depths of Neptune, and felt the profound patience of worlds that take centuries to complete a single orbit. You are a part of this vast, quiet system, not just an observer but a participant, woven from the same cosmic stuff. The iron in your blood was forged in the heart of a long-dead star. The calcium in your bones was cast out into the galaxy in a supernova's final, gentle sigh. The very atoms you breathe are ancient immigrants journeying for billions of years to become part of you here and now. Tonight, as you rest, the solar system continues its slow, silent turn. Jupiter's storms gently churn. Saturn's rings of ice quietly collide. Comets in the deep freeze far beyond continue their patient sleep. And you are floating within it all, a small, warm world in the darkness, held by the same physics that guides the planets in their endless, graceful dance. Let these thoughts go now. There is no need to hold on to them. Your mind can drift away from the orbits and the moons, back to the quiet of this room, to the soft weight of your blanket, to the gentle rhythm of your own breath. If you are still awake, you can watch the next chapter. But for now, I hope you sleep well and dream softly of silent, star-filled skies. Good night.